Good morning. So today we see about the components of basic pneumatic trainer kit. So in that very basic component, nothing but FRL. So FRL full form filter, regulator and lubricator. So this is a common compressor power source or the fluid power. So we have separately kept the compressor at one room. So in that they generate the 5 bar of pressure, so that can be supplied to this FR unit. So here we have the regulator, lubricator as well as a filter. So though we are commonly control the 5 bar pressure at the compressor itself, here we are placing to monitor the amount of pressure reached in that particular pneumatic trainer kit. Okay, so this component we call as a FRL unit. Okay, so after that we need the common junction port. So through that we are able to get the FRL source or the main power source to the different components. Let's go to the individual component. So the very basic component nothing but 3x2 push button. So 3x2 push button control DCV. So here, so the naming itself we consider here 1, 3, 2. So in the case of pneumatic circuits or hydraulic and pneumatic, so odd number indicates input, even number indicates output. So the component which can be the port which can be placed nearer to the muffler. So this we call as a muffler or noiser or noise reducer, or in the case of silencer. So this part we consider as a input for this particular push button. This will be the output. Okay. So we are going to given the supply FRL supply to the input port 1. Then we are getting output in the port 2. So it can the muffler head or the silencer head can be used to release that compressed gas to the atmosphere. So that's the purpose of muffler here. So this we call as a 3x2 push button operated DCV. So this is another 3x2 push button operated DCV. So in the push button operated DCV, so here the input can be placed at the bottom, then output can be placed as the top. So how we are taken this as an input, how we are taken output based upon where the muffler or silencer present. So the nearer to that port we called as a input. So opposite of that port we called as a output in the case of 3x2 push button operated DC. So next component we called as a 3x2 pilot operated DCV. So 3x2 pilot operated DCV. So in that experiment itself they clearly mention the diagram. So circuit symbol of or the graphical symbol of 3x2 pilot operated DCV. So here the number 3 indicates a number of port, the 2 indicates a spool movement or the how many position. Okay, so the 3 ports concern nothing but so port number 1, port number 3 and port number 2. So always odd number indicates input, even number indicates output. So the partition, so this we having some partition in that. So this port we called as a pilot operator. So the name of this component, so 3x2 pilot operator spring return DCV. So that's the name of this particular component. Okay, so I already told that. So where are the places we are having the muffler or silencer, so nearer to that port we called as a input port. So that's a port number 1. So next component we called as a 5x2 pilot operator DCV. So the name, so here circuit symbol they having that 5x2. So the name itself the port number 513 and 42. So in the case of odd number it indicates a input, then the even number indicates a output. So the 2 partition here one, here one. So this we called as a pilot operator. So one end of the pilot operator, then other end. So though it called as a 5x2, so the 2 position it can be controlled by means of pilot operator. So the source we are taken as a input source what we are using. So the same source can be used to actuate the particular DCV. That's why they call as a pilot operator DCV. So naming of the port. So this is a port number 5, 1, 3. So this indicates 2 and 4. So the number 1, port number 1 is always indicate where we are going to use a FRL source. So that we call as a 5x2 pilot operator DCV. The next component we call as a solenoid operator 5x2 DCV. So previously we are having the pilot port. So there is some partition in one end and other end. So in that we are connected the FRL source to operate the particular DCV. Here we are having the solenoid. So both end it can be having some relay coil. So in that, if we supply the positive and negative power supply to that particular relay coil, okay, so the coil will get energized, then make the spool movement inside the valve. So suppose we go for energizing this with the help of positive and negative power supply to this particular relay, so they will get energized, they will make the actuation towards this end. So the actuation inside this DCV can be done by means of this electrical power supply. So we call this here solenoid operator 5/2 DCV. So the port number, so 1, 5, 3, 2, 4. So in the case of odd number always indicates a positive, even number always indicates a negative. So here these two component we call as a muffler or silencer. So here only we are going to take the FRL source or the pilot source we have taken from the FRL unit. Okay. So these both then we are going to given with the electrical power supply to energizing the particular coil. So both then based upon that they will able to make the actuation inside or the two position. 5 nothing but 5 port. So the two position left or right, that can be determined where we are going to energize the electrical energy. So based upon that they make the output to the port 2 or port 4. Next component we call as a limit switch. So here also we call as a 3/2 DCV. So lever or roller operator DCV. So the lower, so here we are having the lower type, or in the case of some mechanical linkage or limit type, it will hit and transfer the input to the output. So where the port nearer to the lever, so it can be considered as a output, then opposite of the port we can say input. Okay, so we are going to transfer the input to the output with the help of the component, the DCV. It can, or the actuator, it hit the roller component, it will push, they will change the direction of this pilot source or the FRL source to the output. So limit switch can be used to identify whether the cylinder will get extended or not. So in the case of sequence of operation, or in the case of AND and OR valve operation of your first exercise, the limit switch will plays major role. So with the help of the limit switch only we are going to make the sequence of operation. So one cylinder will get extended and go for the next cylinder. So that type of operation, this limit switch will be very much helpful to make the sequence. So this valve we call as a flow control valve. So even though we are using the 5 bar pressure, so if you want to go for any flow reduction, or in the case of if you want to reduce the actuation of the any one of the double acting cylinder or single acting cylinder, so in that case we go for flow control valve. So with the help of this knob we can able to reduce the pressure or the flow of pressurized air inside the wash. So that's the purpose we are using the flow control valve. So this valve we call as a OR valve. So we are having the two inputs 1 and 3, and 2 will be the output. So inside that we are having the ball type spool movement. So where the place 1 will get energized, so the ball move towards the 3. Now we are able to get the output through the 2. So if we are going to give the energizing, or we are giving the power supply to the 3, the ball inside the wall, it can be moved towards 1. So now from the power flow can be from 3 to 2. So the purpose of OR valve, so wherever a single input can be getting, we are able to get the output. So in the case of AND gate, OR gate, the same circuit we are using with the mechanical component of AND valve, OR valve, we will go for making the simulation with the help of this AND and OR valve. Okay. So next, this is a AND valve. So wherever two inputs, so whenever we are getting the two inputs, that time this valve able to produce one output. So name itself 1, 3, 2. So odd number indicates input, even number indicates output. So two inputs, and the valve is able to receive the two inputs, that time they are able to produce one output. So in the case of AND valve, so this we call as a OR valve, this we call as a AND valve. So this is single acting cylinder. So we are able to give only one input. So in the rod end, so with the help of the pressurized air, it is able to get the extension. Attraction can be done by means of spring return. So while circuit drawing, you are inside the single acting cylinder, you go for drawing the spring. Inside that piston, we are able to draw some zigzag line, so that we call as a spring. So the retraction of the particular cylinder can be automatically happen with the help of spring, extension and traction. Okay. So extension can be done by means of source, a pressurized air source. So able to make extension. If you release that source, it automatically go for the retraction. So in the case of single acting cylinder, actuation can be done only with the help of single FRL source. Double acting, here we have the double acting cylinder. So we have two ports. So one has a rod end and piston end. So in the case of extension, we are going to give the power supply to the rod end, so the piston able to get extension. If you give the power supply to that piston end, so the actuator go to retraction. So extension retraction can be done by means of two power source. So we are going to give whether the rod end or piston end. So in the case of single acting cylinder, extension can be done with the help of the source. So retraction can be done automatically by means of spring retraction. Okay. So in the case of double acting cylinder, both extension as well as retraction can be done with the help of two sources. So this is the final component of pneumatic circuit. So the circuit connection between the valves, which can be with the help of the hose or tube through which the pressurized air can be flow inside this. So we are directly insert with the from the FRL source to the where we are needed the source. So with the help of this hose only we are going to transfer the pressurized power from the compressor to the FRL to the valves. So the purpose we call this as a hose or tube. So this is a air compressor. So with the help of this compressor only, we are going to take a normal atmosphere air into compressed air. So here we are maintaining 5 bar pressure of air. So we are having some gauges. With the help of this gauge, we are able to measure the 5 bar pressure of air. So normal atmospheric air can be converted into pressurized air of 5 bar with the help of this air compressor. So this is the final component of hydraulic pneumatic. So thank you. So if there is any queries,